Hello, welcome to lesson 2 of CE 5361, surface water hydrology. And this lesson is largely show and tell on how to use a shared resource, which I have highlighted here on the navigation bar, but I'm not going to navigate there yet. The URL for the class is www.rtfmps.com, as you may recall from lesson 1 that was mentioned. And if we go into teaching and the content repository, and when we go to the content repository, this is what we see. This is lesson number 2, so if I take the lesson tab, choose lesson 2, Computational Hydrology, we have the standard lesson layout, and for what it's worth, the data directory is empty, the scripts directory is empty, video at the time of making this video is empty. All that should be there is presentation files. There's a PDF version and a PowerPoint version of everything. I think for today's video I'll just use the PDF version. I may change that depending on how it looks. So wait for it to load. Okay, we'll go to the PowerPoint. Let's see if it'll download it. It will. Good. On my computer I don't have a PowerPoint plugin installed, so I actually have to download and look at the files, which generally is, in my opinion, a better way to go. Okay, so here we are, lesson 2. I'm entitled it Computational Hydrology to be consistent with what the lesson's about. And in this lesson, I'm going to show you the Share Hydro, which is a desktop as a service web service that's housed on a server that I administer, and I will provide you with passwords to that server for your use. If you need to install onto your own computer, these are the 4 primary computational tools that I intend to discourse upon during this class. R, and then I would recommend the RStudio IDE environment, HECHMS, SWIM, and PeakFQ. So what is computational hydrology? So I looked all over the internet for some definitions, and I kind of chuckled while I did that, because at the time I created this topic title, I had no idea there was such a thing. But the best definition I can come up with is the development and use of tools to simulate and investigate the hydrological cycle, and in this case terrestrial, that means on the Earth. The main points are simulating interactions between various components of the hydrologic cycle, investigating the effects of change on the cycle, performing forecast studies for drought and stream flow, although honestly that's more of an engineering application of hydrology, a computational hydrology, and then developing and analyzing large data sets. And we will, in the course of this class, hit on all 4 of these items. Some not in very much detail, but nevertheless, they constitute the topical coverage. So it says use of tools. Well, to use tools, you have to have a toolbox. And so in the toolbox are software. And the ones for this class are R and RStudio, HECHMS, SWIM, and PeakFQ 7.3. So you can go to the internet and find each of these on your own and install them on your machine, and that'll be sufficient. But as an experiment, I wanted to try something called desktop as a service. And so Share Hydro is a web service implementation of that concept. It runs on a server that I lease, and the name is interesting because there is a what do they call it? A cyber infrastructure called HydroShare. And that I think is supported by National Science Foundation and the Consortium on Hydrologic Research, blah, blah, blah. That kind of is aimed at doing the same thing but on a much bigger scale. So what Share Hydro is, and we'll demonstrate it shortly, is it's literally a web portal to a desktop on a server somewhere. To move files between your Share Hydro site and your local computer is done through the Moodle Learning Management System, which we demonstrated in lesson 1. So that you have to log into your Moodle site, and you use the private file section of your account to move it. And then building models in Share Hydro. I mean, it's just regular HECHMS, SWIM, or R, except you're working through the web browser, and the work occurs on the remote machine. Okay, so there's no super advantage to doing that, except that everybody is in the same environment. So any problems one person has, we all have. And it has the attractiveness from a administration perspective of if something's broken, I only have to fix it once on the Share Hydro server, and it's fixed for everybody. So what I'm going to do next is demonstrate Share Hydro. And there are currently 5 portals: Share Hydro 1, Share Hydro 2, 3, 4, and 5. I'll show you how to get to those in a second. And there's a web password for Share Hydro 1, Share Hydro 2, 3, 4, 5, all the way up to whatever X is. Those will be assigned to you by email. I'm going to demonstrate with Share Hydro 1, which has some stuff there already that you won't find in the other portals. Nothing software-wise, just some files, so that I could demonstrate that it works. So I'm now going to escape that. Let me put this over here. I'm currently doing some uploading, so let me check on that. That's good. And there we go. Want to be sure we're back on the server. So here we are back on the class server that's currently not behaving quite properly. Go to the home page. Go to the server home page. Oh, I could have taken the Share Hydro link right up there. All right, so to get to Share Hydro, you click on this navigation link on www.rtfmps.com. And it looks like this. So it's showing a couple of portals open right now. We'll use portal number 1. And what's currently installed is SWIM 5, HEC 4.3, R, and Peak FQ 7.3 is not working correctly yet. So at the making of this video, that was not available. So I've just clicked on Share Hydro 1, and it's negotiating a connection with a remote server, taking an unusually long time. And this is what we expect. So no VNC is a software application provided by an open source project. When I press connect, it's asking us for a password. So on your home machine, it'll probably give you a warning that the website's not secure or something like that. And the warning will be right on top of here, right on top of this password entry. So you have to kind of move that out of the way and enter the password. So the communications is not using encryption, but your passwords are sent encrypted. Data moves back and forth unencrypted, but all the data that's moving back and forth is literally pixels on a screen. So if someone were to intercept it and know that it's a VNC connection, then they could look at what you're doing, but there's no files per se being actually moved. Okay, so the password is, this case is the password for portal number 1, which I won't say out loud. Press send password, and with any luck we'll get a desktop. This error is standard. So just ignore it. And then I want to make better use of my screen, so I'll do that up here, and we'll go to remote resizing, which I think is what I wanted. Yes, that goes to full screen. Okay, now this tab over here on the left is pretty important. When we're done with our connection session, we're going to want to use this bottom deal right here to disconnect. You want to remember to disconnect from the system so that you can renegotiate a connection in the future. If you forget to, if you just close it, just close this tab, most of the time that'll work, but sometimes it gets hung and I'll have to go in and log into the main server and restart everything, which is not the worst thing in the world, but it'd be nice to avoid that. Now here we have some launcher scripts. There's one here called Launch RStudio, Launch HECHMS, Launch Swim. So we'll start with RStudio, and to launch you have a choice. You can double click on it, or if you're like me and you don't trust it, I right clicked, press the execute button, and then wait. And as Tom Petty and the Heartbreakers reminded us, the waiting is the hardest part. And now we have loaded a copy of RStudio, and there's some stuff there. I wonder if I should run this. I'm not going to run it because in case I don't have it set up right. So let's go open a file. I'm going to go one that I know is there. And in the desktop, there are R scripts, my R scripts, my test plot. So that's the first R script. Choose open. It's not much of a script. It's going to plot y equals x squared for x taking on values of 0, 1, 2, 3, 4, and 5. So I'll highlight everything and I'll press run, or I could choose source. And bingo, it's drawn the graph. So that is our RStudio environment. And if we're to save the file, it's saving on the remote. For grins, let's just look at another one. We'll go to lesson 12 scripts, which we'll see when we get to lesson 12. And I have a reason for doing this. So we're now going to switch to that file, uhexample.r, the kill test plot. And the important thing is this particular file is reading data. So you have to be sure that the development environment is pointed to the correct directory. Now for me, the easiest way is to go set working directory to the source file location, and now it has it lesson 12 scripts right down here, unit hydrograph, and now it should be able to do its thing. I'll just run the file. So if I press source, what that does is it's going to run through the entire file. And boom, it made some unit hydrographs. So I'll quit the session. Alright, so that was R Studio and R scripts. Let's do the next one, which is HECHMS. And again, we can launch it the same way. Find the launcher script, right-click, execute. But just to be sure it will work, you can also double-click, and we'll see if that's going to load. Yeah, it did. Now I'm curious if I'm going to load two instances. While I'm making this video, I'm experiencing a lot of internet lag. So when I move the window, you can see it sort of dragging its way across the screen. Depending on the network load at wherever you're working from, the lag might be better or worse than you're seeing here. So the lag is occurring on the network. It's not occurring at the remote end. The remote end is a very high-end server provided by a company called Just Host. They're out of the United Kingdom, and I think the machines are physically sitting on an abandoned oil platform in the North Sea. So here's HECHMS, and I have a project there already called My Live Model. Not very exciting, but we'll go click on it to verify that it's going to run. And there's the model. There's a watershed here, here. See if I can do a little bit of redrawing. Again, the network lag is problematic. Yeah, I knew there was more up there. Ah, that's better. Zoom in and out. Okay, there's our topology. Watershed called West, North, and Eden, and they're connecting through some sort of channel. They drain into a reservoir, which drains to a channel, all of which is coming to some junction. Okay, so that's the model, and to verify it's going to run, go to simulation runs, run 1, and run the simulation. Ta-da, it ran. And I'll pick the junction, just plot some graph. And there's the graph for junction 1. And I'd have to revisit the actual conceptual model to understand what we just plotted. If we pick one of the watersheds, that might be helpful. Or subbasins. So yeah, there we have a typical subbasin. Up at the top of the graph, you have the precipitation. The loss is plotted as red, so what's left over is the excess precipitation. And then there's the outflow from that watershed, which is a 6 square mile watershed with a lag time of 165 minutes using an SCS dimensionless unit hydrograph. And a curve number method for the loss with a curve number of 79, almost 80. Okay, well that concludes our HMS demo. So we'll exit. Well, sure exits quick. And the last one we want to do is swim. So what I've done is selected the launcher, double-clicked on it, and again we'll just open an existing file. I think there's one on here already. So that's a swim model. Perhaps if you're familiar with the software, you've seen it like this. We can load the backdrop. There's the backdrop, which kind of clutters things. The backdrop looks like it's a screen capture from a computer. Looks like Windows 7. Let me unload the backdrop. Done. And I'll run the model. It's already set up to run. And so we've done each of these subbasins. Subcatchment is the concept used in swim. They're about 3 acres. So we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 20 times 3. So this represents about a 60-acre area. And if we're to look at our rain gauge, it's cumulative. Let's see, 4 hours and 4 inches. Okay, so it's 4 inches an hour. And 60 acres. So if we look at the discharge in this last element, which is a conduit going to the outfall, or even the outfall itself, but these last two elements take all the flow. At 1 inch an hour, once all the runoff is started, we would expect about 60 cubic feet per second if we were to plot the flow in that. And, well, a little bit more. We get more. So my areas are bigger than 60 acres. Nevertheless, the behavior is what's anticipated in this simple model. And we can even have more fun. We can plot so I think it's going to draw a profile along that line. Oh, it actually worked. Okay, cool. And if we run map and look at time, I believe it's a 6-hour simulation, we can see the water coming up into the system and hitting equilibrium value. And interpreting these graphs, when we get later on in the course, I'll explain how to do that. And that is the Share Hydro modeling environment. And now if you want to move files to and from, I'll show you how to do that. We would use our Moodle site. I'm going to go ahead and load the web browser here in the Share Hydro environment. Whoa, it takes a lot of real estate. Here's the Moodle site for class, and we want to use surface water hydrology. Should get a login screen. We're going to log in as James Bond, who's a student in the class. It's not a real student, but this is just what I use for a fake student. You can ignore that security warning. It's a true statement. The connection's not secured, but the user ID password are sent encrypted. Okay, his password is also his name. Log in, don't save. And cool, there we are. Maybe move it around just a touch. And I'll show you how we do files. So keep in your mind, right now there is a window to a remote server that's open. And that's in Safari, so let me try FireDog, and I'm now back on my local machine, and I'm going to open the same thing. And so now James Bond is logged in here, I hope. Okay, cool. So there's this file right here, flow duration 1 PDF. We'll go take a look at it. It's a flow duration, a paper on flow duration curves. Actually, something we're going to study later on in the semester. Let's say we want to move it to share Hydra for whatever reason. In our Moodle account, go to private file. And make some real estate. I will delete that one. I will delete that one. Save the changes. And I'm going to move flow duration curve to private file. And what's happening now, it's uploading to the Moodle server. Remarkably fast for my home network, which is a whopping 27.7 dial-up server. So one of the wonderful things about work at home is it builds your patience. My network provider is AT&T, and they are no longer able to meet the terms of the plan that they sold me. They can't hit the network speeds that they claim. Their option by telephone is to upgrade to a even faster thing. My response being, why would I trust you to go faster when the one I have is already slower than you said it would be? That was my rant for the video. I hope I remember to edit this section so that you're not sitting there watching a progress bar work its way across the screen. And the file is almost there. I hit Save Changes, and we've uploaded it. Now let's move back to our Share Hydro screen. And we go to Private Files. It's there. Select the file. Download it. It's now in our Share Hydro workspace. I wonder if that will actually work. I don't think it will. So we'll just save it. And it saves to a place in our home directory called Downloads. And I may not have a PDF viewer installed at our remote site. The remote is mostly intended for computation, so now Google Chrome does have a PDF viewer in it, so when you want to look at your PDFs, open them up in Chrome. And ta-da, we've moved the file to our Share Hydro site. Now to move the files from Share Hydro back to our home machine, we do the identical process in reverse, just pass everything through the Moodle site. So for instance, well, we'll just grab something out of EPA Swim projects as a demonstration. So we'll take this text file. I just want to be sure it was something uninteresting. So we drag it there, hit Save Changes. And sometimes you got to be kind of patient. What I'm trying to do is renegotiate the connection with the server to get the file. So there it is. We can download it. I'll just go ahead and download and open it. And same file. So we moved files there, we moved them back. So the intent for Share Hydro is to do your computation there and then move your results back to your home machine for writing any reports and handing stuff in. And then you would upload your stuff to the Moodle website. And that concludes most of the function. So I'm going to close everything, and then like I mentioned, try to remember to disconnect, and then once disconnected, it's safe to go back to our main environment, back to teaching.